students. So in this class we are going to study work done by variable force. So what is a variable force? A force whose magnitude keeps on changing either with respect to time or with respect to displacement. So if we have an object of mass m and if we have applied a force whose magnitude keeps on changing with respect to the displacement it has caused. So if consider an object of mass m and if we have applied a force whose magnitude is changing with respect to the displacement it has caused, then we call it as of variable nature. Similarly, if its magnitude is changing with respect to time, then we call it also as of variable nature. So such that if I have already taken the example, it can be its magnitude changing with respect to displacement or its magnitude changing with respect to time. Now, and also it may happen that its direction is changing. So if I talk about the direction changing, then that variable force is a centripetal force. So if we consider a circle, and in a circle if the object is of mass m is revolving around the center, then its magnitude is changing with respect to time. Now its magnitude remains same, but its direction is changing with respect to the revolution. So we call it as a variable force. Now we have to find out that what will be the work done in the variable force. So to find the work done by a variable force, we can know that the work done, we have to find the work done by a constant force. So if I have an object of mass m and a force is applied which is of constant nature. Constant nature means its magnitude remains same with respect to the displacement it has caused. So its magnitude remains same with respect to the displacement it has caused. Now if the object is displaced by, let's consider x distance. So the total work done will be equal to force into x. Now if I call about, this is the total work done by the constant force. Now if I draw the variable force graph, then if we have an object and if the force is of a variable nature, now in this case we have to find what is the total work done when the force is of a variable nature. Variable nature means its magnitude is changing with respect to its position. With respect to the displacement it has caused, its magnitude is changing. So now in this case we call it as a force which is of variable nature. Now how can we find out the work done in this case? So to find the work done in this case, what we can do, we can consider an at x distance a dx element. So we have considered at x distance a very small element which is of dx thickness. So we have considered a very small element at dx distance which is of dx. Now for this dx infinitely small element, what we can assume that the magnitude of this force remains same, because this infinitely small element which we have considered. So this infinitely small element dx which we have considered is actually a very small value which is 0.0001. So for this dx element, the magnitude of the force is same. So the magnitude of this force is same for this dx element. We can calculate the total work done for this dx element. So let's consider here the force is f dash. So for this dx element thickness, let's consider the force is f dash. So the work done is equal to f dash into dx. So the work done for this is, because we already know that for a constant force, so if the force is of a constant nature, then the total work done is equal to the total force which is of constant magnitude into displacement. Now, in the case of the variable force, if we have a dx element thickness and the magnitude of this force will remain same for this dx element, so the work done can be written as F dash into dx. And in order to calculate the total work done, we can integrate both these sides, because to calculate the area of the graph which is of variable nature, what we have to do, we have to integrate. So in this case, we can integrate both the sides, and on integrating both the sides, here we get the total work done and here we get the total force, total F dash into dx. So we can integrate both this function with respect to the dx element and we will get the total work done. So this is the total work done by the variable force. So the force whose magnitude is changing with respect to the displacement, we can calculate the work done. Now, we will now consider certain examples in the practical which of the forces which are actually of variable nature. So first, let's consider if we will consider a small element mass m on this earth, and as if it is kept at an h distance. So for this mass m, the magnitude of the force is constant, which is mg. But if I come, so this gravitational force which acts on this mass m due to the surface of the earth is actually constant. So we will count this force as of constant nature. Now, if we consider a spring force. So what is a spring force? The spring force whose magnitude keeps on changing with respect to the displacement. So if we have applied a force on this spring, if we have applied on this spring a certain amount of force, then this spring is extended, or if this spring can be either extended or this spring can either be compressed. So if we have applied a force and on this spring which has a spring constant K, now on applying the force, this spring, let's assume this spring is extended to an x distance. So the force which is acting on it is Kx. So the force which is acting on it is Kx. So here we can note that the force is of a variable nature. So this force Kx is of a variable nature whose magnitude is changing with respect to the displacement it has caused. So this spring force will be counted in as a variable force whose magnitude is changing with respect to the displacement. So at a particular extension x, its magnitude is given by kx. So the spring force is basically a variable force. Now let's consider another example. What we have two charges. And if we come to the electrodynamics, if we have considered, let's consider there is charge 1, Q1, and there is another charge Q2. And if these two charges are kept at a certain distance, then the force acting on any of the charges, we can consider. So if we can consider this Q2 charge, then the electrostatic force acting on this charge is Kq1 Q2 upon R squared. So the magnitude of this force is changing with respect to the distance between these two charges. So the magnitude of this force is changing with respect to the with respect to the distance between them. So we call it as of variable nature. Now, so this electrostatic force is a variable force. We can also consider an example by universal law of gravitation, like if we have two planets of mass m1 and m2, then at kept distance r, so the force which is acting is gm1 m2 upon r square. So this force is again of variable nature. So these are certain types of variable forces whose magnitude is changing with respect to either time or with respect to either the displacement it has caused. So now we will consider a certain examples that how can we find the magnitude of this variable force. So we can assume now an object of mass m. So if we have an object of mass m, and let's consider the force is applied on this mass m is equal to 5x. Now we have to calculate the work done. We have to calculate the work done when this object is on, when the object displaces from x equal to 0 to x equal to 5 meter. So the total work done in this case will be equal to, we know already that the work done by a variable force is equal to dW is equal to force into displacement. So we can integrate both the sides. Force is 5x into dx and it's integrating from x equal to 0 to 5 meter. So we can write it as on integration. This on integrating this 5x, what we can write 5x square by 2. So we can write as 5x square by 2. Its magnitude is going from 0 to 5. We can put this value, and on putting this value we can calculate 125 by 2 joule. So this is the total work done by the variable force, which is equal to 125 by 2 joule. So this, in this case, when the force is of a variable nature. Now if I talk about the work energy theorem for the variable force, then what will be the work energy theorem for this variable force? So what is basically a work energy theorem? Work energy theorem states that if we have an object of mass m and if there are applied n number of forces, so if there are n number of forces being applied on this object, so the total sum work done by all these n number of forces. So total work done by n number of forces is equal to change in kinetic energy. So this is actually the total work done by the n, when the sum of the total work done by n number of forces on this block of mass m is equal to change in kinetic energy. So now if we talk about the sum of the total work done, then if the work done force is of variable nature, what we can write it as force into dx. So if the force, if this is the n number of force, and what we can write it into dx. This is the total work done by the variable force. Now this force can be written as mass into dv by dt into dx. And now this dx by dt, this dx by dt is equal to velocity v. So this dx by dt can be written as velocity v. So this is equal to mv dv by dt. So we can integrate this we can integrate now this both the sides, and what we get mv square by 2, and whose magnitude is going from u to v. So this comes out to be equal to the total change in kinetic energy. So this is the total work done by n number of forces, which is equal to the change in kinetic energy. Okay students, so now let's consider the example for this. So if we have an object, and if we have an object of mass 2 kg and whose velocity is equal to alpha root x, and we have to calculate the total work done when what will be the total work done when x is equal, when the object is going from x equal to 0 to x equal to 5 meter. So now work done is equal to, we already know, change in kinetic energy. This can be written as half into mass, which is equal to 2 kg. Final velocity v equal to alpha root x, so it can be written as alpha root 5. square minus its initial kinetic energy. Its initial kinetic energy is equal to half